So the idea of transformations. Once we know the basic curve, we can now transform it to other things. So the idea of shifting curves horizontally and vertically. Remember, so if we had function x plus or minus a, or another way of thinking about that is when the shift is grouped with the y, then we have a vertical change because it's grouped with the y. So say there's random curve, there's function x. If I wanted to shift the whole thing up a, so that point goes up a, oh, so does that one. Oh, and those. We get this red curve, which would be function x plus a. Whereas a horizontal shift is when it's grouped with the x. Now, if you're ever unsure where the shift's going to, just ask yourself, what would make that equal to 0? So if I wanted to shift to the left here, b units, and so every point would go across b units. There we go. That would be x plus b, because I've shifted it to negative b. Okay, the idea of stretching curves. This is when we multiply by a constant. So if we multiply the whole constant times the function, or another way of thinking about that is, again, the constant is grouped with the y. So it must be vertical shift that's happening. So that would be k times function x, where k is bigger than 1. Because basically we're saying every y value is going to be a number bigger than 1 times it. So instead of, say it was 2 times function x, instead of having a y value of 1, I've now got a y value of 2. Instead of 3, I've got 6. So it must have shifted it that way, or stretched it that way. If I wanted to make it shallower, then I'd multiply by a number smaller than 1. Now, when we're stretching vertically, the domain is not going to change, because all I'm doing is stretching it vertically. The range might change. I mean, in this case, the range was all real y, so it's not going to change. But for some functions, the range might change. The x values of all those key points stay the same, but obviously the y values change. And the x-intercepts would stay the same. So anything to do with x stays the same. The other one then is when we group it with the x, but notice I've written it as x divided by k here rather than times k, because then that gives us the same sort of idea. If I divide by a constant number bigger than 1, I'm going to push it in. And if you prefer to think of it as a constant times x, well, in that case we're saying the constant is bigger than 1. And stretch it out, it'll be the other way around. Again, if you're unsure of the stretch, sub a number in, see what, where it's gone to. In this case, the y's are staying the same, so the range would stay the same, but the domain might change. The x-intercepts might change, the y-intercepts will still be the same. The y value of the key points stay the same, but the x values change. Y equals negative function x. So that's where we reflect in the x-axis. So there's random curve. If I wanted y equals negative function x, well, let's have a look at the key points. They're all going to reflect through. Whoop. There we go. And we get y equals negative function x. Whereas function negative x, that reflects in the y-axis. Same idea, look at your key points, reflect them, and there's function negative x. Here's an interesting one. Function 2a minus x. I've made it 2a to make the calculation easier. Some books you'll just see it with a minus x. Well, it's just a constant at the end of the day. That's where we reflect function x in the line x equals a. So it's a combination of a shift and a reflect. But if you see it straight away, rather than thinking how do I build it, you can say, oh, well, that's just going to be a reflection in the line x equals a. And that's why I made the constant 2a. So replace x with 2a minus x is basically what we're doing. And so there's our curve. If I put a There we go. There's a green line for x equals a. So same idea, but now I'm just reflecting through a different line. So we get the key points and reflect them. Oop. And there it is. That would be 2a minus x. So some books will say just a constant minus x, but then you'll be reflecting in the constant divided by 2. So now, that was the horizontal one. The vertical one would be like that, would be 2a minus function x. So that one's been shifted up, but we get a reflection in a. So where it is, there's x equals, or y equals a. And the same idea, but we're just reflecting through a different line. So that one's, I don't know, we talked too much about that when we looked at shifting in that last year. Come on. Okay, so the Cambridge exercises I've attached, just a handful there to look at.